Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper trending on X, published on December 4th, 2025, about 1 week ago. This paper shows that a Gemini-based embodied agent called SIMA2 effectively doubles average task success over SIMA1 while still retaining strong general reasoning and language skills, and it can even keep improving itself through experience in new virtual worlds. The paper is titled SIMA2, a generalist embodied agent for virtual worlds. And as we will see later, the results for general game playing and self-improvement are really impressive. Alright, Figure 1 pulls everything together visually. The large central panel shows SIMA2 in No Man's Sky, receiving a natural language prompt, reasoning about the goal, and then acting to inspect the egg-shaped objects. On the right, the upper bar chart compares success rates, where SIMA2 roughly doubles performance relative to SIMA1 and moves closer to humans. The lower curve illustrates self-improvement, as repeated learning iterations steadily raise the agent's average score beyond the human reference. Along the bottom strip, diverse training and held-out environments highlight how broadly this single agent operates. Well, Figure 2 makes that breadth concrete. The large image grid shows dozens of different video game scenes, ranging from bright indoor labs and cartoonish sandboxes to dark alien landscapes, icy tundras, and busy control panels. This diversity means the agent must cope with wildly varying three-dimensional layouts, camera views, and menu systems. Because the same single agent trains across all of these worlds, it learns general embodiment skills instead of memorizing one game. Alright, Figure 3 walks through how the agent actually plays a game like a human. The left panel shows the text prompt, current frame, and goal, which together define what the player wants done. Across the middle row, successive frames show the agent moving in the kitchen while emitting low-level keyboard and mouse commands. Along the bottom, blue boxes display internal reasoning and dialogue, so the same model explains what it is doing as it acts and knows when the task is complete. So, after seeing how the agent reasons step-by-step in individual games, Figure 6 summarizes how that translates into overall success. The bar chart shows that SIMA2 roughly doubles the success rate of SIMA1 on both human-judged and automatic evaluations. Human players without time limits still lead slightly, but SIMA2 nearly reaches their performance. With time limits included, SIMA2 actually matches or exceeds many human runs, which highlights how efficiently the agent uses its action budget. Alright, while Figure 6 compared overall success on trained environments, Figure 10 shows how the agents cope in completely new worlds. The bar chart reports success rates in the held-out games ASKA and MindDojo. In both cases, SIMA2 jumps from near zero to around 15 to 18% success, beating SIMA1 by about 12 to 13 points. That gap shows that the newer agent really does generalize, not just memorize specific games. So while the previous figure highlighted generalization to new games, Table 1 summarizes how much reasoning ability the agent keeps after embodiment training. The 3 rows cover coding, competition-level math, and difficult science questions. The drops after supervised fine-tuning stay around 4 to 26%, and reinforcement learning makes them only slightly worse. That pattern shows the agent gains strong control skills, while mostly preserving its original language and reasoning strengths. SIMA2 shows that a single Gemini-based agent can both act in complex three-dimensional worlds and keep much of its original reasoning power, while even improving itself through experience. This points toward future agents that learn continuously and bridge virtual and physical tasks. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.